Welcome to Econ Talks with Mr. Hyatt. Today we're going to go over production possibility curves and tables. So our learning target for today is production is based off of the evaluation of trade-offs. So it's important that we understand what a trade-off is today. Your success criterion is you will be able to identify key vocabulary and explain a production possibility graphically and orally through proper models and with given information. So what you're going to do is you're going to watch two videos from Mr. Clifford today that go over production possibilities and key information, and then the last part of the video is me showing you how to complete the actual graph based off of the table. So make sure that you stay tuned with all three parts and you pay attention to the vocab that we need from this. So the vocabulary. The first piece of the vocabulary you're going to need is opportunity cost. That's also trade-offs, as we mentioned them throughout this. You also need to go over increasing opportunity cost, which turns into marginal return. We also want to look at efficiency, inefficiency, and unattainable or impossible as points on a graph. What is the production possibility table and or curve? And constant opportunity cost, as well as factors of production, which there are four. All right, I'll catch you later. Now, Mr. Clifford, take it away.
Hey, how you doing, Econ students? This is Mr. Clifford. Welcome to ACDC Econ. Right now, you're learning about the first graph in this class. It's called the production possibilities curve. The production possibilities curve presents potential prospects for the production of a pair of products. It's a pillar of the program, and pupils have to practice. This graph is totally important. First, we're going to start off with a table that shows the production possibilities of two goods. In this case, videos and hats. And this example is actually for me. If I quit teaching, I spent all my time, I could make hats, right? Using this loom, hats that look like this. Basically, you wrap the yarn around this and it can wrap around itself and the hat kind of grows out from the bottom. You kind of tie it off to the end. As you can see from the chart, if I spent all my time working on hats, I could produce 30 hats in a week. Yo, what's up, bro? If I spent all my time and resources making econ videos, I could make 4 videos. But as you can see, I wouldn't be able to make any hats. So this chart shows my production possibilities. It shows me the different combinations of hats and videos that I could make using all of my resources. To get the graph, we just have to plot these points, and that's going to give us a graph that looks like this. This is the production possibilities curve, or sometimes called the production possibilities frontier. The best part about this graph is the fact that it shows all the key concepts that you've been learning so far. It's going to show scarcity, trade-offs, opportunity costs, and efficiency. It shows the idea of scarcity because it shows that I cannot produce anywhere beyond the curve. So the curve, or the frontier, shows the idea that I have limited resources. The graph shows trade-offs because if I decide to start producing videos, I have to give up hats. Or if I produce hats, I have to give up videos. Opportunity cost is shown by the specific number of hats I give up when I make a video. For example, when I move from combination A to combination B, I'm producing more videos, but I'm also losing hats. The number of hats I lost is the opportunity cost. In this case, producing the first video cost me 1 hat. This graph shows efficiency because if I'm producing a point right here, where I'm producing only 2 videos and 5 hats, I am inefficient. This is because I'm not using all of my resources to the fullest. I'm not somewhere on the actual curve. So any combination inside the curve is inefficient because I could produce there, but I don't want to. I can produce more of both goods. That means that the line itself must be the idea of efficiency. If I'm producing any one of these combinations, I'm using all my resources to the fullest. And again, a point here outside the curve is impossible because I don't have enough resources to get there. But the curve can shift, but wait for it, that comes later. Right now it's time for you to practice calculating opportunity cost. So I want you to use the table and figure out the opportunity cost from each one of these. So calculate the opportunity cost from A to D, to B to C, from E to D, and from C to A. Remember, opportunity cost is what we're giving up, and so look for the thing that we're losing. Don't forget to clarify if I'm giving up hats or if I'm giving up videos. The opportunity cost from A to D is 15 hats. Notice, from combination A, we're producing 0 videos and 30 hats. Now, when we go over here to D, we're going to have 3 videos and we're going to have 15 hats. That means we lost 15 hats. That's the opportunity cost. The opportunity cost from combination B to C is 4 hats. The opportunity cost from E to D is 1 video. And the opportunity cost from combination C to combination A is 2 videos. Now, it's super important to be able to calculate opportunity cost, but we're not done. Let's do different examples. So in this case, let's do corn and wheat, and let's do cactus and pineapple. It turns out that the shape of the curve is very important. So this top one shows a constant opportunity cost between corn and wheat. This is because the resources to produce corn and wheat, the ground, the climate, are very similar. So when you produce a certain amount of wheat, you give up a certain amount of corn. And when you produce that same amount of wheat, you give up the same amount of corn. That shows constant opportunity cost. But down here, when it comes to cactus and pineapples, when you produce the very first pineapple, you give up just a little bit of cactus. When you produce the next pineapple, you give up even more, the next one even more, and the last one, a whole lot of cactus you give up. This is called increasing opportunity cost. It's because the resources, the land and climate to produce pineapples and cactus are completely different. But the plural of cactuses is cacti. What? Cacti! 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 So when we first start producing pineapples, we're going to give up just a little bit of cacti. This is because we're going to use the land that's more suited towards pineapples, and it's not very good at producing cacti, and so we're going to lose a little bit of cacti and get a good amount of pineapples. Now, as we keep doing that over and over again, we're going to give up more and more cacti. This is because we're using resources that are less and less suited towards pineapples, until finally, right here, we're producing just a little bit more pineapples, but giving up a whole lot of cacti. Cacti! And this is the idea of the law of increasing opportunity cost. The law says as you produce anything, the opportunity cost to produce it is going to get bigger and bigger. And that explains the shape of the graph. Remember, a straight line production possibilities curve like this shows constant opportunity cost, and a bowed out curve shows the idea of increasing opportunity cost. Now, if you like this video, make sure to subscribe, and you can learn more about the production possibilities curve and how it shifts by clicking on this video, or you can go look at Unit 1 videos by clicking right here. Now, make sure to come back to the channel because I'm making a ton of new videos this year, all right? Till next time. The production possibilities curve, the production possibilities curve presents potential prospects for the production of two products, a pair of products. The production possibilities curve protects. Why would it protect? How you doing, Econ students? This is Mr. Clifford. Welcome to Econ Movies. In previous episodes, we learned about scarcity and choices. Now let's see how these concepts affect producers by looking at Disney Pixar's Monsters, Inc.
The future is bright at Monsters Incorporated. We warm your home. We light your city, carefully matching every child to their ideal monster to produce superior scream, refined into clean, dependable energy. Every time you turn something on, Monsters Incorporated is there.
To produce things, we need resources, and economists argue that all resources are scarce. Sometimes these resources are called the factors of production. They are land, labor, capital, which is like the machinery to produce things, and then someone to bring it all together, the entrepreneur.
This company's been in my family for 3 generations.
Economists like to explain the idea of scarcity by drawing something called the production possibilities curve. The PPC is a graph that shows how an economy can use its resources to produce 2 different goods. So let's assume that Monstropolis can only produce 2 different products, Scream Energy and sushi. This graph shows the production possibilities, the different combinations of the 2 goods that can be produced using all of their resources. As you can see, they can put all their resources to produce Scream Energy, or they can produce all sushi, or some combination in between. But notice they can't get any combination outside the curve. They can't put all of their resources into producing Scream Energy, at the same time put all those resources into producing sushi. So any combination out here, outside the curve, is impossible. And now's a good time to talk about the difference between consumer goods and capital goods. Consumer goods are obviously made for consumers, made for direct consumption. These are things like cars, odorant, and snow cones.
Snow cone?
No, don't worry. It's lemon.
Capital goods are made for indirect consumption and are basically tools and machines to produce consumer goods. Now let's analyze the big problem in Monstropolis, the Scream shortage. They clearly explain the cause of the shortage.
Kids these days, they just don't get scared like they used to.
This means that the main resource to produce Scream Energy, the children, are less productive.
What happened?
The kid almost touched me. She got this close to me.
She wasn't scared of you? She was only 6!
I could have been dead. I could have died.
Now, back to the graph. What happens to the production possibilities curve if a resource becomes less productive? The entire curve shifts inward. Now, you should be thinking to yourself, I can see why we're producing less Scream Energy, but why are we producing less sushi? The reason why is because Scream Energy is a capital good. It's a resource. If you don't have Scream Energy, you can't even run a restaurant.
Without Scream, we have no power.
Now, what if there was some new technology that made the resources that produce Scream Energy more productive? That is, what if there was a way to get more Scream?
Uh-oh. Oh, come on. No. Come on. Hey. The thing is moving. I don't like big moving things that are moving towards me. No, come on. Hey, Randall.
Say hello to the Scream Extractor.
Hello.
In this case, the production possibilities curve would shift outward. We can produce more of both goods. But at what cost?
Scaring isn't enough anymore.
But kidnapping children?
I'll kidnap 1,000 children before I let this company die,
And I'll silence anyone who gets in my way!
Well, it turns out that you don't have to kidnap children.
Great job, Mikey. You filled your quota on the first kid of the day.
Not bad, huh? You know, only somebody with perfect comedic timing could produce this much energy in one shot.
Uh-huh. And the fact that laughter is 10 times more powerful than scream had nothing to do with it.
In the end, huge productivity advancements shift the production possibilities curve outward and lead to happiness and prosperity. The production possibilities curve is the first of many graphs you're going to learn in economics. Don't give up if you don't fully understand the graph at first. If you stick with it, eventually it'll all make sense.
Thank you for that, Mr. Clifford, and that entertainment. Now let's go to Mr. Hands. Hi, Mr. Hands. Mr. Hands is going to help us go over how to create these curves based off of a table. So a PPT, or production possibility table, is the table that gives us the information that we need to fill out our graph. So they're both telling us the same thing. One is just a table giving us the data, and the other is a graphic representation of that same data, because people like graphs. So you'll notice that I'm setting this up a little bit different than you saw Mr. Clifford do it. So my first column is going to be called a row. That's our points to be graphed, A, B, C, D. We give them letters on this particular graph. So in our row, the next thing that we are going to do is look at which one of our products we're going to produce. So the first thing we're going to start with is WMDs. For those of you who don't know, that's weapons of mass destruction. I try to choose things that are going to stick with you. All right. Going from weapons of mass destruction, the next thing that we'll look at producing is Barbie dolls. So our two choices are Barbie dolls, weapons of mass destruction. So our company makes one or both of these. So if we make 5 WMDs in a certain time period, we cannot make any Barbie dolls. So if we put all of our production value towards WMDs, we make absolutely no Barbie dolls. For every 1 WMD we don't make, we can make 100 more Barbie dolls. So if we take away 1 WMD, we can make 100 more Barbie dolls. So with each one that we take away, we make 100 more Barbie dolls. This, as you might have noticed, is what we call a constant opportunity cost, and we'll go over that in a second. Now, obviously, Models isn't making WMDs and Barbie dolls, and it's going to be a little bit more complex than that. But really what we're going over right now is how to graph the information. So between the two choices our company has to make, we have, again, WMDs and Barbie dolls, and at the very end, we can make zero WMDs and 500 Barbie dolls. And now we've completed our chart with our rows A through F. Those are our points. So now we want to figure out how to do opportunity cost. Well, at the start, there is no opportunity cost because that's our starting place. So at 5-0, there's none. How do we figure this out? Well, A minus B over A minus B. So we go from point to point. So going from A to B, we lose 1 WMD, and we gain 100 Barbie dolls. So -1 over 100 is our trade-off, or our opportunity cost, from going from A to B. If we go from B to C, again, it will be 1 to 100. Now, depending on what points we're going to, it will change what that is, but as we can see that this is going to be constant if we go from point to point. Now, if we were going to go from A to F, it would be -5 over 500, which is still going to be -1 over 100 in a simplified fraction. Okay, so in the end, our trade-offs in this instance are going to be constant, or they're going to be a constant opportunity cost. If there was a bowed out to the curve, it would be what we referred to as increasing opportunity cost, meaning the more resources we use, the less we would get out of them. But we're going to get into that later in this week. Thank you, Mr. Hands. Let's move on. All right, so let's set up our graph. So from our graph, we're not going to use 4 quadrants. We're just going to use the top right quadrant from what you're used to in math. So you're going to have a vertical axis and you're going to have your horizontal axis. On a production possibility curve or frontier, it doesn't matter which product you put on which axis. So I'm going to put Barbie dolls on the horizontal axis and I'm going to put WMDs on my vertical axis. Now, what is important is that I meter the graph correctly. So if I'm going to put WMDs, we know that I'm going from 0 to 5 in my production. So what I'm going to do is every 2 inches I'm going to make a mark for the production of 1 unit. And it'll go 1 to 5 since I know I end at 5. Now, I do not have to use the same measure when I do my Barbie dolls, but I have to make sure that the measure on the entire line stays consistent. So again, I'm going to go every 2 inches and make a mark for every 100 Barbie dolls that I'm going to produce, since I know that I'm going to max out at 500 and label them 100 to 500. Okay, so it is important that your meter is correct, though the meter on the 2 lines can be different because your production possibilities are going to be different. Now I'm ready to graph. So if you remember our first point, point A was going to be 5 WMDs and 0 Barbie dolls. So if I go straight up to the line to 5 WMDs and 0, which is right on the line, that's going to be point A. My next point was going to be 4 WMDs and 100 Barbie dolls. So I'm going to draw my dotted line over to from 4 to 100 and fix that a little bit. You should use a ruler when doing this. It's a little bit harder when I'm doing it on a board. All right. And my next point, point C, was 3 and 200. B, C. All right. My next point was 200 and 300. And there's point D. And then my next point was 1 and 400. Oops, went a little too far. And there's point E. And if I make 0 WMDs on the horizontal axis, I make 500 Barbie dolls, so there's point F. Now this should be a straight line since it's constant opportunity cost all the way up. Now, I can also do my opportunity cost or trade-offs right here on the graph. So if I just go from point A to point B, I can see that I go down 1, which is -1 WMD, and I go over 100. The rise over run. The slope of the line is between 2 points is going to be our trade-off. All right, so we're going to make a couple other points that you need to graph on here. So we're going to put point X down here below the line, point Y up here above the line. Now, point X is what we're going to call inefficient production. Anything below the line that we drew is inefficient production, meaning that we're not utilizing our resources to the max of their capability. Points A through F are all efficient production. At any point, if that's what we're producing, we're doing it efficiently. Point Y is unattainable or impossible. We just lack the resources to be able to achieve that goal at the current time. Now, we're going to talk about other things here in the future about how we can shift out of production possibilities so that we can eventually reach out into those frontiers. But for right now, what we need to know is how to graph this line. Thank you, Mr. Hands. All right, so from here you should know how to utilize a production possibility table to create a production possibility curve and figure out opportunity cost. All right, guys, I'll see you tomorrow.